Hey guys, it's Miss Buck. So here's the video for task 2, so you can kind of see what to do with that. Make sure you're all good to go. Let's see. So I'm going to go to Canvas. Just open that up. Remember that the videos and things that are embedded, I'm not going to click and play those all the way through. You can, but we expect you to watch. If there's a video clip there, again, we expect you to watch it. Let's see. I haven't published it yet, but I will. But one thing I want you to notice, I'm scrolling down, is it says task 2. It's not due until Monday. So again, we're trying to give you guys plenty of time. This is new for us. It's new for you. We know you have different subjects you're working on. So we wanted to just have you work on, give you time. All right. So this isn't due till Monday. The other thing that I'm trying, I don't know if it will work, is I thought if I put a new task on Monday morning for you and you get a chance to look at it, that way on Tuesday in the Zoom meeting, you can ask me any questions about it that you don't understand. Then on Wednesday, I'll put another task. And then that way on Thursday, hopefully you can get on Zoom and ask me any questions that you need, and then that'll put you in good shape to finish it. All right, so here's task 2. Same standard that we're working on, all right? So, and you'll see this time we are going to start looking at how do we look at fossils in a sedimentary rock layer and start pulling out information about those fossils and about what has happened based on the patterns that we see. So we want to see, we're going to look at these fossils for evidence that we had different living things that have existed on the planet. Again, no dinosaurs in my backyard anymore. We certainly have lots and lots of different living things. We know that some living things have gone extinct, and we can see that by looking at the fossil record. And then we can see how some living things have changed over time. And so that's what we're focusing on. You will, again, have a note sheet that you're going to fill out. So I'm going to click right here so you can see. Same deal, guys. It's going to automatically make a copy for you. Here's the copy. It's this little blue right here. And I would click on that so that you can work on there and have this open and not have to be trying to fit it in here. Okay. So I'm going to leave mine right here, but I would really, for you, I'd click right there. When you are done, because a couple of you have tried to share that Google Doc with me, and that gets dumped into no man's land. When you're done, you just go all the way back into Canvas, just pretend you're logging in again, and you will have a submit button. And you click the submit button, and then it will come through for me on my end. We're going to start you right off in just a minute and ask you to watch a short video clip about evolution, and we'll talk in just a minute about that, because I know that that's always, some people hear that word and they have some misconceptions with it. They kind of have some ideas about that word that they come into class with. So I want to make sure we set the tone for that. But as you're watching that, we want you to fill out this table. So we want 3 things that you notice, just 3 observations that you make as you're watching the video, and then 3 things that you wonder about, or 3 questions that you have as you watch it. So you're going to fill this table out. I think the rest of it is pretty self-explanatory. There's another table down here that goes with another video that we have. We filled a little bit of the table in for you. And then as you watch the video, you'll complete this table. And then at the very end, we do have, we have a song. You'll like it. It's called the Fossil Rock Anthem. You need to listen to it. And then there is a website that we want you to go to. So we kind of have reminded you on the note sheet as well that we need you to practice that. Okay. All right. So, I suggest that you open this up. All right. So you got that all nice and open. And then you are ready to go ahead and use the Google Slide presentation. So I embedded it for you. Okay, so it's right there. And this Google slide presentation is just about fossils and evolution. And we've put something on there. It's called the Tree of Life. And you'll see a lot of times when we go through this life science unit, we talk about the Tree of Life all the time. And they can look, you'll see different ways that people draw them out. But here's one, and it's got some bacteria over here. It's kind of like tree branches going off. There's that weird word protista, or I just call it the protist kingdom. That's our little single-celled amoebas. Let's see, there's our plants. That's the fancy, I guess, Latin word. Here's our mushrooms and yeasts and molds. There's our fungi. Here's our animals. Oh, look, there's a little penguin at the top. Ooh, is that a whale? I can't tell. It looks so little. So we put a question. Why is the tree of life a useful analogy to understand the history of life on Earth? In other words, at the end of our life science unit, if we give you this, would you be able to really go into a nice discussion for us of exactly what this means? And so hopefully you'll be able to do that. There's the standard again. Before we get started, we always want to set some ground rules when we get into this topic. It's a complex topic, guys, because we're talking about how living things have changed over time. And this, again, is one of the topics that we want to remember that we're in science class. And so we're looking at the science explanation for things. And remember that science only uses what we can actually observe and measure as evidence. So science doesn't concern itself with trying to explain things that can't actually be observed or measured. And so we are looking at the science explanation for how living things have changed over time. So right off the bat, we have a short, I think it's about 10 minutes maybe, video on evolution. And this is a very nice, simple explanation. So please make sure that you're filling out the data table on your note sheet. And remember, you can watch this 2 or 3 times if you need to. That's the nice thing about just doing it at home, doing it on your own. But when you watch that video, one thing that the person doing the video is going to say over and over is this definition, that evolution is any change in the heritable traits. That just means traits that are passed down within a population. We're referring to a population is a group of living organisms. You could have a population of butterflies. You could have a population of roaches. You can have a population of red kangaroos. So it's a change in the traits that are being passed down that occurs in that population across generations. So that means, as generations here, referring to, obviously you're used to having maybe grandparents and then parents and then you, so across generations. So and this word heritable traits, hopefully you remember from last year, you guys did a little bit of work with your Punnett squares and your genetics, and talked a little bit about how those traits get passed down. It's important to remember when we talk about evolution that we don't want to get confused. We don't ever just look at one individual and talk about it evolving. So I would never look at just one butterfly and talk about that one butterfly changed and call that evolution. Populations can evolve and change over time, but not just one individual thing. Most of the time, evolution is something that occurs over millions and millions of years. And so again, that's where that scale, proportion, and quantity can get us in trouble, because we have this tendency to think about, that this is something that happens quickly. We have some examples of evolution that occurs over a lifetime in a way that we can get some evidence from it. But most of the time, we're talking about things that occur over millions of years. Okay. So we're just going to look at the science evidence to support this theory. And so the big piece of evidence when we talk about how do we know that living things have changed over time, we have lots of evidence from the science point of view, but the biggest piece of evidence we have is because we can look at the fossil record. And so that's why we wanted to make sure you understand where we find most of our fossils. And we're going to take a little bit of a look at how fossils form. And so right here, we kind of have some steps for how something might end up as a fossil in some sedimentary rock. All right. Now, one thing I want you to notice when you click here, it's going to pop up and say video unavailable, but right below it, it's going to say watch this video on YouTube. And if you click there, you will be able to watch it. You're going to have I think it's like a sharky, fishy looking thing. Let me see. Here it comes. Yeah. Embrace yourself because it's going to die. It's going to die and it's going to become a fossil. But it's all right. You can name him. We'll call him Ralph. Ralph is going to die there, but it'll be all right. So usually what happens is we have something that dies, and if it gets buried quickly enough, and it doesn't decay and just have other things come and eat it, and it starts to get buried by just dirt and rock and different kinds of organic little particles left over that accumulate and pile up on top. And in sedimentary rock, the most typical thing is that the hard parts, not the soft, squishy parts, those are going to rot. But the hard parts of our little shark thing, its bones, for example, will slowly get replaced by minerals. And that way, it can become a fossil. And if somehow then that fossil gets exposed at some point in time, and if somebody happens to discover that fossil, then we get a piece of evidence. So I had a kid one time ask me, I thought it was a great question. I remember he said, well, how old does something have to be a fossil? And I thought, I don't know. So we went and looked it up. So a fossil, we're going to say it's the preserved remains or traces. It can be a trace of something, of a living organism or something that used to be a living organism. So if I found a tool, a metal tool from some ancient civilization, that wouldn't be a fossil. That's an artifact, but it's not a fossil because it was not ever alive. But when we looked it up, it turns out that scientists have kind of decided that it's got to be at least 10,000 years old to be considered a fossil. So we just put some examples. Here is an example of something called a trace fossil. So it is a dinosaur footprint. It's not the dinosaur itself, but a trace fossil can be something that the living organism left behind. So it could be a footprint. It can be dinosaur poop. We have fossilized dinosaur poop. It can be a tunnel. We have fossilized tunnels, and that's a trace fossil. Here's an alligator fossil. Can you guys see it? That's the alligator head right there. I guess that's his body back through there. And then here's a fossilized shell, okay? Why are they so important? All right, these fossils give us all kinds of evidence for how living things used to look. And boy, some of them used to look very different in the past. We also get clues about how things used to behave. So, for example, we have found fossilized remains of dinosaurs, of many dinosaurs together in one place. And that tells us that at least some species of dinosaurs probably lived in groups, okay, like a herd of something, for example. So that's a behavior. We also can get clues about how the Earth's environment has changed. So if we find a fossil of something that we know must have lived in the ocean, and we find that here in Upper East Tennessee, then that tells us that probably at some time in the past, this land that we're living on now must have been covered by ocean. And then we also can look at the fossil record, and we look and we look and we get to a point, for example, where an living organism disappears from, we have no more fossils. And that gives us a clue that that living organism probably must have went extinct. So we can actually pinpoint pretty well when the dinosaurs went extinct by looking at the fossil record. Most fossils do form in sedimentary rock. And if you're a geologist, that's going to be a place that you immediately go and look. But there are some other interesting ways that fossils can form. So we have this video for you, and you'll like it. It's pretty funny. There's a paleontologist in here that's pretty funny to listen to him when he talks about things. But you're going to see some other ways that we can have things turn into fossils. And then I think you have a table to fill out in your note sheet. I do think it's always important to remember the fossil record is not complete. Most living things, when they die, are just going to decay, all right? And they're just going to disintegrate and go back into the earth. So most things don't turn into a fossil. And then you have to remember that living organisms that are made mainly of soft body parts don't usually fossilize. Now, there's some exceptions to that. That's why if it gets trapped in amber, that's kind of a cool thing, because then you do get like a fossil of an insect. But for the most part, you're not going to get jellyfish or worms or things like that, because they're just all gushy. And so they don't have any hard body parts that can get replaced by mineral. Even if something becomes a fossil, most fossils are going to just be destroyed. I mean, look at what we talked about. We know the continents are moving. We know we have divergent plate boundaries and convergent and our transform boundaries. Things are moving. We have earthquakes. We have volcanoes. So even if something does become a fossil, lots of them are destroyed. And then even if it's not destroyed, it's got to be found, right? Somebody's got to find it. So most scientists think we have about 10% of the fossil record represented by the actual fossils that we have. So this is kind of what I tell kids. Pretend you've got a puzzle and it has 100 pieces. And I give you 10 pieces. That's it. And I tell you, all right, based on these 10 pieces, I want you to tell me what the picture is. Well, it kind of depends on the 10 pieces you get. If you get 10 pieces that aren't very good and they're just kind of the outside little border pieces, you might not be able to tell a lot. But if you get some really good pieces, get a piece with an eyeball on it or something, you're not going to have the whole picture, but you got something. And that's kind of where we're at with the fossil record. We've got some good pieces. We don't have the whole record, but we've got some good pieces. So most fossils are found in sedimentary rock, and that sedimentary rock, remember, makes layers. Okay, it makes layers. And one thing is, if we have what we call undisturbed sedimentary rock layers, then we have a certain law that we use that gives us some information about the age of the rock layers and the age of the fossils that are in them. And it's called the law of superposition. It says sedimentary layers are deposited in a time sequence. In an undisturbed sedimentary rock layer, the oldest layer is on the bottom and the youngest layer is on the top. So remember what I said, the farther down you dig, the farther back in time you go. We can date rock layers and fossils in a couple of different ways. One way is called relative dating, and that's what we just did. Relative dating, you're only stating whether a fossil is older or younger than another fossil based on where it's at. All right, and we just did that. If we look at this again, I can say this fossil is older than this fossil. That's relative dating. But we also can do something called absolute dating. We can use radioactive elements. I don't know if your seventh grade teachers talked with you about half-lives, but we have some radioactive elements that are naturally radioactive, and we know that they decay over time. And that word decay means that its radioactivity gets less and less over time. And for many things of these elements, we know how long it takes for that to happen. So we can use that information and we can look at a rock layer or a fossil. And by looking at the rock layer and looking at how much of that radioactive element is left over, we can get an idea of the age of it. And so you'll hear a number with absolute dating. All right. So if I say the fossil is 240 million years old, then that's absolute dating. So right here, this fossil is in this layer. This layer has been dated with an absolute date of 570 million years old. And so an absolute date would be if I said this fossil is approximately 570 million years old. That's absolute dating. If I just say this fossil is older than this fossil, then that's just relative dating. All right, so we're going to start to put all this information together. So what scientists did is they took undisturbed rock sequences from all over the earth, and they took each one and thought of it as like a puzzle piece. And they fit them together in order to get this big old huge rock sequence that we call the geologic timeline. So I'll show you. So it's kind of like if we took, we'll pretend this is some sedimentary rock from, I don't know, Peru. I don't even know if Peru has sedimentary rock. And we took this sedimentary rock from Wyoming. And we took this sedimentary rock, this chunk right here, from Africa. And these are our three puzzle pieces. And we sort of fit them together. We look at their age and we piece them together and we make one big geologic column. Okay. So how exactly do we do that? Well, all right, we can remember, we can use radioactive dating and we can kind of get an approximate age for these, and that helps us fit our puzzle pieces together. But the biggest way we do this is by using something called an index fossil. So I want to show you what an index fossil is and how we use it to line up our rock layers, okay? All right, so we have a little definition of an index fossil for you. An index fossil is an organism that lived in a specific geologic age and is used to identify or date the rock layer in which it's found. We have a very short video for you where we're going to talk about that a little bit more, but please watch it because you're going to need it to do this. So I'm going to walk you through a couple of these so you can see how this works. All right, so each of these is called an outcrop, and that's just a word that means just a big chunk of sedimentary rock, okay? So here we have 1, 2, 3, 4 sections of rock. And again, you can pretend we got there, that came from Tennessee, and that's from Australia, and that's from Russia, and that's from, I don't know, wherever else you want it to be, okay? So can we figure out, when we look at this, we want to start thinking, first of all, about which fossil in here we could use as an index fossil. All right. Well, the first thing, in order to be an index fossil, it's got to be something that is very widely distributed. That means we find it in lots of places around the world. So when I look at this fossil, for example, you notice that it's in this sample of rock, but it's not here. I don't see it here. I don't see it here, and I don't see it here. Well, that's not going to be useful to me as an index fossil. I have to find a fossil that is in all four of these, okay? All right, so it can't be that one. That's out. All right, well, let's see. What about this one? That's cute. Looks like a little, I don't know, seashell, little apple pie. All right, I see it there. I see some here. I see it here. And I see it here. Okay, so that's good. So it's widely distributed. But to be an index fossil, there's something else. It has to only live in one rock layer. Well, this one is only in one rock layer. See right here. And this one, it's only in one rock layer. But I have a problem right here. See, it's in 1, 2, 3 different layers. So to be an index fossil, it needs to be widely distributed around the world. So that is, but it also needs to be very what we call short-lived. It needs to occur in only one layer. So I can't use that one. Well, what about this thing? Well, immediately I see I got a problem because it's in 2 layers. So that leaves me with this. Let's check. It's here, it's here, it's here, and it's here. So it's widely distributed. Okay, there it is, no problem. And in each section, it only occurs in this one layer. So what that means is now anywhere in the world where I find this fossil, this index fossil, I can know for sure, I can date this layer and I can know for sure that it is of a certain age. So that would be the index fossil. All right, so how do we use it? Okay, well, here's how we use it. We have 3 different outcrops. Look at this big mess. I have a bunch of fossils in here, and I want you to figure out, these are our 3 puzzle pieces, and I want you to figure out how in the world to put these 3 together. Like, where do I line them up at? Which layer ends up the oldest and which is the youngest? Well, first thing, goodness gracious, first thing I got to do is find an index fossil. All right, here we go. I'm going to find one. Can it be this thing, which I have no clue what that is supposed to be at all? There it is. I see it here. I see it here. Ooh, look, I've had some uplift there, and that tells me that I'm missing a layer. Anytime you see a little jagged line, tells you something kind of weird happened there. I see it there. But that fossil isn't here. So I can't use it as an index fossil because it's got to be in all 3 of these sections. I don't know what that's supposed to be. It kind of looks like me on a bad hair day. I don't know. It's kind of hard to see. But I know one thing. I don't see it here, and I don't see it here, so I can't use that. This looks like a broom. I always think this looks like a walking broom, like it's a broom, like that should be its little head, and it's going to walk over there. But I see it here. It's not here. It's not there. Can't use that. What about this thing? It's there. It's here. And it's here. Ooh, that's good. That's good. So it's in all 3 of them. And second thing I have to go back and look, is it only in one layer in each of them? It's in one layer. It's in one layer. It's in one layer. So that means layer A, layer K, and layer Q are the same age. And here's what it looks like then. I can line those up. I know for sure that those are the same age. So I would line them up. And then I would be able to say for sure that layer F is the youngest layer because it's at the top. And then we get older and older and older. Right here, these are the same age. And then I could say for sure that layer E ends up as the oldest. And so that's kind of the idea here. We did one more, pointing out that we have a curvy line right here. So what if I asked you right here if you could put all of these layers in order from youngest to oldest, just based on their relative age, okay? Well, I might be able to use that as an index fossil. Might be able to use that as an index fossil. This wavy line shows me, what that usually shows you is that there was a layer there, and it's somehow there's a missing layer between this one and this one. There was maybe a layer there, maybe it got destroyed or eroded, that they're trying to show me that something used to be there. So let's see if you can get this right. Did you figure it out? Okay, these two could be used as an index fossil. Then I'm missing a layer right here. Layer E used to be there, but it's gone. So that tells me that that one is the next youngest. Then those two. And then the very youngest would be my little fish. So if I was actually putting kind of, these two are puzzle pieces I'm putting together. Here's my youngest. Those two are a little older. This is next older. It's just that I'm missing it right there. And then these are the oldest. Here's a fossil rock anthem. Listen to it. It's good, I promise. It's fun. We wouldn't put it in there if it wasn't cute. And then we have a website. Now, guys, don't blow this off because you're going to take a little quiz for us. But this website, there's some games here, and you're welcome to play them. They're pretty fun. There's a bunch of neat ones here. But the one that we want you to do for sure is called Layers of Time. I think it's got some little music with it. Oh, there's our flash player. Let's get my flash going. Ah, there's the music. All right. I'll turn the music off. So it's going to give you a little bit of information again. It's going to show you how those fossils get trapped in that sedimentary rock. It's also going to tell you that the time span that a species exists can be seen as what we call a column, extending through the rock layers. Once a species becomes extinct, it disappears from the fossil record and the column ends. You can't have something go extinct and then be gone for a couple of layers and then pop back up. Now, that can happen with uplift and some things like that, but if it's an undisturbed sedimentary rock layer, once it goes extinct, it's extinct. So we like this a lot because I'm going to show you how it works on level 1. Every time you do this, it kind of pops up a different thing. This is the easiest one. Notice that it says oldest layer. So I can drag that down here. There's my trilobite. So I can't have the trilobite here and then have it disappear and then pop back up. So I know I got to pull that down. So now I have trilobite, trilobite. Now it can disappear because it doesn't come back again. Oh, look at that little thing. That's an interesting looking thing. Well, here he is, and he's up here, so I got to pull that down. Let me see. There he is. That's all right. Now he can disappear. What is that? A pterosaur. Is that how I say it? Tucker would know. All right, but look, he can't disappear and pop back up. I got to pull him down there. Let's see if I'm getting there. Trilobites, and I've got those. And I've got those. Let me check this out over here. My birds. Now, see, that popped up and was here and then went away. I don't know. Let's see. I'll check my work. Oh, good. And I like this because you can hover over them and it gives you a little bit of information about it. Okay. But here's the cool thing. I like this. You can click play again. And I can pick level 1 again. And look, it gives you a different practice, okay? So you need to spend some time on this and get comfortable with it, with the game. So I would do, level 1 and 2 and 3. They get harder. See how you do with those, all right? Because you are going to notice then that you will submit your note sheet through Canvas. We're reminding you to play the game, and then look what it says. You are ready to take a quiz about the information in task 2, and you'll click there to take the quiz. Now, yeah, you're at home. Use anything you need to help you out with the quiz. You'll see it says insert my video. That's the video I'm making right now. So that will pop up and be in here if you need it. Okay. And yep, so you can use all your notes and things, but do make sure that you practice a little bit with that game. And like I said, there's a bunch of cool things on that website. I have fun messing around with them. So you can look at some of the other games on there as well. All right, I think that's got you set for task 2. So I think that's it. Okay.